Today we're going to take a look at statistical tests that come from a grouping of quantitative methods that all encompass comparing group means within quantitative research. So every test that we're going to talk about in this segment is really going to be related to comparing different groups and how they are going to perform by looking at their means. And so in order to do that, the tests that do that are called the paired samples t-test, the independent t-test, the one-way ANOVA, and the two-way ANOVA. All of these tests in different ways are going to compare the means across different groups. So if you think about it, if you're trying to compare any type of grouping of students, you're going to be in one of these tests. So the first test is a paired samples t-test. And what this is really a test that compares two related measurements from the same individual. So we say related measurements for a couple of reasons. So this is most often connected to the idea of a pre-test and a post-test. But we know from the educational world that there is some bias in giving the exact same pre-test and the exact same post-test. So when we say related measurements, that's leaving the door open that it may not be exactly the same test. Maybe it's the same objective for each question or the same assessment piece for each question, but they could be asked in different ways. And the way this test is strategically utilized is that it comes after some type of an intervention. So let's say that you have students in a reading class, they take a pre-test, then you're going to teach an in-depth new lesson with different strategies on reading comprehension, and you want to know, does that actually make a difference in doing that? So this test would let you look at that pre-test score and then look at that post-test score, and you're determining basically the success of the intervention based on the fact that if the average score increases by a statistically significant amount. Now, notice I didn't say mean score increases in game. I said it increases by what we call a statistically significant amount. And again, we can all take an average of a pre-test and a post-test, and we can say it went from this to this. The idea of this test is that statistically significant, which means it is enough of a change that we can't say it's due to chance that these students just happen to improve. So the benchmark for statistically significant is saying that there is a threshold that's being calculated in SPSS in the background based on the number of people you have and a lot of other factors. And we need to make sure that if we're saying that this intervention is what increased the score, then we have to be sure that it's not due to some random chance, due to guessing, due to other factors. And so that's kind of the key of this test. In all of our other tests, it really focuses on change across different individuals, and individuals aren't tested twice. This test is really focused on change for the same participant from test A to test B after some type of intervention has been given. So when do we use it? We use it in that pre-test, post-test environment. Typically, if you are looking to find out if some type of training, professional development, curriculum, intervention, leadership summit, any of that, if you're trying to say that there is, or trying to study if that improves anything, you are looking at a paired samples t-test. If that is the focus of your topic, would be looking to see if an intervention, a professional development, a curriculum, a different teaching strategy, a leadership summit, any of those types of things, if you're looking to say that this thing causes change, then you are a paired samples t-test. In order to be on this, though, you have to have a continuous dependent variable, which means It has to be a scale value score. So you can't necessarily use a Likert scale here. So this is not going to work on a self-reporting survey. This would work in, I'm going to give you 10 questions, and then I'm going to grade the 10 questions, and you get an 8 out of 10 or a 9 out of 10. That will work. So you can't use Likert surveys in a paired samples t-test. You can't have the thing that you're measuring the change between, that pretest and that post-test. That has to be a scale continuous variable. You also have to give them at 2 different times to the same participants. If, let's say, participant 1 doesn't show up on the day of the post-test, participant 1 is excluded from the group, because we have to have 2 scores at 2 different time points that are happening, where one is clearly happening after the intervention, the training, the professional development, whatever you want to look at. And so our research question is always looking to find out if there is a change within that person that we can say is attributed by the thing that you're trying to study. And so for our variables, we have this implied independent variable. We call it implied because it's really not a variable, but it's just saying that we gave you a pretest and a post-test. That's our variable, test type. It's not truly a variable, but it's just clearly saying this score belongs to the pretest, this score belongs to the post-test. And then that dependent variable is that continuous value that's being measured, and it has to be interval or ratio, a test score. If it's an anxiety rating, it can't just be a Likert scale question. You're going to have to literally do a survey that has a subscore, kind of like your DSMs have, like your Vinelands, where there's actually some type of algorithm or metric to the scoring. You cannot just give a generic survey and say they got 27 out of 30. It has to be a vetted instrument that has an algorithm for how you're calculating the anxiety rating. And that scale would have to be the same at both time points. And so, importantly, we use the term within subjects to mean the same person takes it twice. And because of that, we don't really call it the independent variable because we're doing it twice. We're just calling it the pretest, post-test, the implied independent variable. And what we also look at here is the order of the subtraction is very important. We take the post-test score and we subtract the pre-test score. So that's what's happening in SPSS when you're calculating this, is it's taking the post-test minus the pre-test, which is really important as we dig into that test. And we need that subtraction to be approximately normally distributed. That does not mean the post-test is normally distributed and the pre-test is normally distributed. It means when SPSS runs this test, it's going to subtract the score for every participant in that way, and then it's going to tell you what the distribution looks like, and we want it to be, again, approximately normal, which means you have some wiggle room there. And the more subjects you have, the more wiggle room there is. So if you're choosing this test for a dissertation study, you would want to make sure that you have over 30 participants. I would say over 50 to 75 would be my perfect world if I was working as a methodologist on this. Here's an example of a research problem that would align to a paired sample t-test. So many districts, they invest a ton in literacy interventions to really try to improve student reading outcomes. But there's not a lot of evidence with a lot of the programs when we go in to look at the curriculums themselves. So the research problem is therefore that we need to examine whether the reading comprehension is actually improving things or not. Now, this is not the formal study research problem. This is just me setting up a problem that the paired samples t-test can solve. Obviously, our research problem is our larger societal problem, but what I mean here is literally this is the problem I'm trying to solve with my paired samples t-test. I want to know, what does this intervention do? Are we getting gains? Are we losing ground? What is it? So If I was doing a purpose statement for a paired samples t-test, then I would say the quantitative within subject study, and then I would use the word compares. You have to keep all of those words there, and then you're going to change out the second half of that sentence based on what you're doing. And then again, in that last sentence, the only thing that's changing is to note reading performance after completing the program. Everything else is staying the same in the template. You're only going to change that last piece of that second sentence. So that's kind of your template for what you would have there. And then your research question, again, very templated. We have to say, is there a statistically significant difference in? Then you would replace what the score is before and after what the intervention is. So that's really what that research question would look like if you were doing a pair sample t-test. Therefore, our null and our alternate hypothesis are going to be there's no statistically significant difference in what you're measuring before and after the intervention, or there is a statistically significant difference in what you're measuring before and after the intervention. And I would probably say as we're moving towards dissertations and studies, we would replace the intervention with what the intervention actually is. In the paired samples t-test, we've got some assumptions. We assume that when we do that subtraction of that post minus pre, that it is normally distributed. And we're going to use a Shapiro-Wilk test to do that because, remember, I'm not looking at the distribution of post versus pre where I can make a histogram. This is actually done within the workload and the process of that paired samples t-test. The scale of measurement needs to be continuous. So I have to say my dependent variable is continuous. And then every participant gets a pre-test and a post-test. They don't get to take an extra test. They don't take them at the same time. They are independent of one another. If we have assumptions that are violated, typically we would want a large enough sample to say that it's okay that we've had a slight violation. But if the violation is egregious, we could change to a non-parametric alternative. Some of the common mistakes with this test is that people get into the mindset that they're comparing two different groups on the same test. That would actually be an independent samples t-test, not a paired samples t-test. And then a lot of times people will use a categorical outcome like something that's pass-fail, something that's a Likert scale, which is ordinal, and not actually doing a continuous thing. And then the other piece is that you have to have a way to track the participants. So that might mean that you're giving them an ID number, and you're making sure when you enter your data that ID 30 has a pre-test and a post-test. So logistically, you have to think your way through how are you going to get that to happen there. The next test is our independent samples t-test, and this means that I have multiple samples that are independent of one another. And it compares the means of exactly two unrelated groups. So exactly two. It can't compare three. It can't compare more than two. It's exactly two. And it's looking for, is there any difference when group A takes this test and group B takes this test? And that again speaks to trying to surface something that's in an inequity. So if your topic is bringing you to a place where you're interested in knowing if there are inequities, then that would be an independent samples t-test because you're trying to look at does one group perform disproportionately compared to the other on the exact same test with the exact same background knowledge with the exact same whatever that is. And that doesn't have to be a test in school. That could be a test where we're giving something after a professional development. That could be something where we're giving an attendance piece or something like that. So that's kind of the key idea, is that it doesn't have to be a traditional test. It can literally be something where you're giving an instrument to measure something. And so it's looking for, not only is there a difference in this when I'm looking at it, but is that difference statistically meaningful and significant between the groups? So what we're saying is when these two groups take this same test, that it's not due to chance that one group does better than another. It's not due to one group getting a different intervention than another. It's not due to any other factor other than the fact that we have some type of inequity situation going on here that we have to look for. And so we need to use it when we have two separate groups. In education, we don't really do treatment versus control group here. Again, if you're wanting to know if something improves performance, that would be a paired samples t-test. But if we were in the medical world, we might be looking at treatment versus control. But really, we're going to be just separating, like, do males perform disproportionately compared to females or vice versa? We need something to be continuous. It has to be a test score, a GPA. A survey can be used here, but again, it's going to have to be a survey that has some type of algorithm, like a DSM, like a Vineland, where it is an official instrument and there is some type of calculation happening that ends in a total score. Each participant can only take it one time. If it's more than once, that's a different test. And then also the design is going to focus on comparing the group means rather than measuring change over time or trying to predict anything. And so here, our independent variable, we call it a grouping variable. So it's how are you grouping people? Is it online versus in person? Male versus female? Protestant versus non-Protestant? Black and brown versus Caucasian. What are those groupings? They must be clear and they must be labeled. So that's our grouping variable. And then our dependent variable is that continuous thing that we are measuring. And so remember, I can only have two groups. That's really key. And then that really needs to be numeric and continuous. And so again, not a research problem in the sense of this is your entire dissertation, societal, big old issue, yada, yada. This is just in this snapshot, we're adopting online instructional models, and we just want to know, is there going to be a difference in performance here? And so our purpose statement, if we were choosing this type of study, is we would say this quantitative between group study compares high school student standardized math test based on their instructional modality. And then you would have that second sentence there. And our research question looks a lot like the paired samples, but you're not going to see that repeated pretest, post-test mentioned. It's going to be, is there a statistically significant difference in high school students' standard mathematics test based on whether they got instruction online or in person? So instead of having that before an intervention, after an intervention, it's going to be those two groups are going to be mentioned at the very end. And so our null hypothesis is always that no, there's no difference in the standardized test score between students who are online versus those in person. Our alternate is, yes, there is a statistically significant difference on that standardized math test for the students who get it online versus in person. Our assumptions are that that dependent variable, whatever that test is approximately normal. Again, the more people in your study, the more we can say, that assumption wasn't quite met, but it's still okay. We need to have a scale of measurement. The dependent variable has to be continuous, and then the independent variable is going to have to be a group that is, again, measured only once. We have a new assumption where we're saying the variance has to be homogeneous. All that really means is that there's a test that's run in SPSS. You're going to look at the output of that test, and you're going to know if that assumption was violated or not. It's a very simple test that you look at. So if those things are violated, it gets a little more complicated in this type of t-test And generally speaking, we would probably say you could use a Mann-Whitney, or potentially you might need to shift to an ANOVA, which we're going to talk about next. Some common mistakes here are when groups aren't independent. So you have the same people taking the same test twice. That's a common mistake. That's paired samples, not independent. Often people will use something ordinal. So in that independent samples, they're comparing letter grades or Likert items. You can't do that with the independent samples t-test. It has to be interval or ratio. And a Likert scale is ordinal, letter grades are ordinal, numeric grades are continuous and A-OK. People will ignore the assumption of equal variances or forget to put it in their results. It's really important that that's in your results. And sometimes they'll mislabel group membership, or they'll try to use this for more than 2 groups, which is a big problem. Our one-way ANOVA, still comparing means across groups, the only difference with this test is that it can do 3 or more groups. So it is the same concept as the independent samples t-test, but I can look at 3 or more groups. And because I can look at 3 or more groups, I kind of have to double check my work, because I'm running a lot of things in the background, and if I'm looking at 3 or more groups, we need to do some test at the end, which we call post hoc test, to really try to identify which groups are differing significantly and literally double check our work. So we're going to run the ANOVA. Depending on what we find, we've got to double check our work. We use it when we have 3 or more independent groups. Same rules. Continuous dependent variable has to be a test score, a GPA, has to be interval or ratio. Each participant can only be in one group, so I can't have any type of world where someone could belong to 2 groups. And the real thing here is that we're trying to compare group means. That is the really critical piece there. And so the variables, I need a categorical factor where I'm grouping people. Again, it's called a grouping factor. So that could be lecture, inquiry-based, flipped classroom. That's a group of 3. It qualifies for an ANOVA. And then my dependent variable, again, has to be that continuous outcome that's either interval or scale. Same idea. Again, my research problem is not your topical problem, but if I'm trying to solve a problem where there are multiple enrichment programs, there are multiple intervention options, there are multiple ethnic groups I'm trying to compare, if there are any of those types of things, there's a comparison. That is when I would want to pull in the ANOVA. And when we do an ANOVA, it looks very similar to a t-test. You really can't tell anything is different until you get to that second sentence. It is, again, between groups, not between subjects, because between subjects would be a paired t-test. Between groups is a one-way ANOVA, independent samples t-test, or a two-way ANOVA. And then, again, our research question looks just like the independent samples t-test. Is there a statistically significant difference in high school students' standardized reading comprehension score based on the type of academic enrichment they participated in? And then I listed my 3 groups in parentheses. Again, my hypotheses. We have no difference in that score based on that, or we have a difference in that score based on what we did. And our assumptions are going to be the same here as the independent samples t-test. I have to have a normally distributed dependent variable, so I've got to do that histogram and look at it. I've got to have scale measurement. Every participant can only belong to one group, and again, I'm going to do that homogeneity of variance. It's a table that it puts out. You just have to check the table and report the findings. If any of these are violated, a one-way ANOVA is actually incredibly robust. If you violate an assumption here, you keep going. So you're not going to have to change to a different test. You might have to do a different follow-up test to check your work. But unlike the independent samples t-test, you have to change. And so a lot of the times I'll say, even though you're working with 2 groups of students, if you're doing a dissertation, you might want to just go ahead and run it as an ANOVA. It is not incorrect to do an ANOVA with 2 groups. And by doing the ANOVA, it is more robust and it can withstand an assumption violation that you don't even know if it's a thing until you have your data. So it can be a really smart thing to do there. So only in the dissertation would I say you can use it with 2 groups. In the real world, you're not doing a 2-part piece like a proposal then a final defense. Failing to check and mention your assumptions. Every time you talk about your test, you've got to talk about your assumptions. People will treat Likert scale items as interval and do an ANOVA. You cannot do that. You can give a survey, again, that has some type of calculation in it that comes to sub-scores or a total score. That's fine with Likert items, but you have to get to that type of thing. Otherwise, it's ordinal. Some people will mislabel things in SPSS, which can lead to problems, and then some people forget to check their work. A post hoc test means you're checking your work. That is a very necessary part of the 2-way ANOVA. Now, the 2-way ANOVA, people often think that that's just the same as a 1-way ANOVA. It's not. So what the 2-way ANOVA looks at is whether a continuous outcome, so whatever that thing you're measuring, differs based on 2 different categories. So here, I can look at race and gender, and I can say, do male Caucasians perform significantly differently than, let's say, female black and brown students on this test? So if you kind of think of it, I'm having 2 different aspects that I'm looking at. And then the really nice piece is it'll even tell me if the interaction of gender and race is significant. So you're going to find out, A, does the score differ between those 2 groupings with that? And then B, does gender and race interact in a significant way? And that's what's really critical about the 2-way ANOVA. So a lot of times people are using a 1-way ANOVA with like 6 groups happening. And it's like, well, wait a minute, do you really want to have 6 separate groups? Or are you trying to look at the interplay between 2 different things? And that would actually be a 2-way ANOVA. So in a 2-way ANOVA, we have 2 grouping factors. So something like instruction type and grade level. That would be what I would have for my independent variable, and then I still have that continuous dependent variable. And the goal is to really look at each of those grouping factors and then understand how they might relate to one another. And so in this way, we say it's again between subjects because someone is going to belong to the male group and they're also going to belong to that racial group. So you can belong to 2 groups here. So this is another place where people try to do the 1-way and they're like, wait, I have to have totally separate groups. Yes, but if you want to have overlap in your groups, the 2-way ANOVA is how you do it because you can look at that overlapping piece through this. And so we've kind of already covered this. You've got 2 independent variables, which are going to be those grouping factors, and then what you're measuring. Our research problem would be something like trying to understand 2 different things, so program type and grade level, and how that's showing difference in college readiness. So again, not overall research problem, but literally that. If I was writing my purpose statement for this, I would say this quantitative between groups, not between subjects, between groups, compares who? High school students, reading comprehension score, there's my dependent variable, across, and then we use the word combinations. Because people can belong to more than one group now, we're going to say combinations of academic enrichment type and grade level. And the ANOVA will determine whether the reading score differ by program type, grade level, and whether there is any interaction between the program type and grade level on reading performance. And so our research question is written very fundamentally the same as all of our other tests, but we're going to say the dependent variable based on program type, grade level, or their interaction. So I've got both independent variables there, and then I have to add the phrase or their interaction on there as well. You have a lot of hypotheses here. You have a group of main effects where you're going to take each grouping factor and write its own hypothesis. So here I have my program types. That's its own hypothesis. And then I have my grade level, and that is its own hypothesis. So I have 2 independent variables. I have 4 main effect hypotheses. Then I have to write the interaction one. And then I'm saying there's no significant interaction between my independent variables, and there is significant interaction between my independent variables. So in a two-way ANOVA, it's not like a standard test where you have 2 hypotheses, because I have 2 grouping factors, so I have to have first grouping factor, second grouping factor, and I have to layer in that interaction effect. We have the same assumptions as we did for the other tests for the one-way ANOVA and for the independent samples t-test. But some common mistakes here are trying to run a two-way ANOVA with 1 independent variable, and that should be either a one-way ANOVA or a t-test. Not checking or reporting interaction effects. I actually see this pretty commonly when I'm working as a methodologist. So people will often get the first 4 hypotheses in there because they know they need them for the groups, but they will forget that the entire powerful nature of this test is that you can look at the interaction too. They will also mislabel categories, and sometimes they will forget to do those post hoc tests, which are really just, again, checking your work. So those are the grouping of all of the comparison tests that compare things. This, again, is meant for you really to just get familiar with what that is. You're not going to be an expert in these today. You're going to watch a video on SPSS and how to do them. And I've got some workbook pages that are currently in development that will soon be a workbook that's published and publicly available. But for right now, it's only available to my fall 2025 students as we're piloting it as a group. So I hope that this has really helped you wrap your mind around the different ways and quantitative tests that all fall under comparing the means. And we'll have further discussion on this in the future as well.